Hello viewers, this is the part 2 of the series named Mastering OEM, where I will cover everything you need to know about Oracle Enterprise Manager or OEM to be able to administer it at its best. So in the first part, we install Oracle 19c software on an Oracle Linux 7.9 virtual machine. In today's second part, we will create the OEM repository database in the Oracle version 19.3 on an Oracle Linux 7.9 server. Here I am using a virtualized environment using Oracle VirtualBox Virtual Machines 6.1 and Oracle Linux 7.9 platform. If you are not familiar with Oracle VirtualBox, please watch my other series on Oracle VirtualBox Virtual Machines and create your virtual learning environment with Oracle Enterprise Linux the easiest way possible in your PC. So let's start today's tutorial by defining the database layout in terms of storage and resource like CPU, memory, swap, and their footprints on the server. I am explaining this through a table. As per the standard definition, an OEM with up to 200 database targets is considered as a small deployment, 200 to 500 as medium, and with 500 plus targets, it is considered as a large deployment. So obviously, our test deployment will be a small one. Now, the CPU. The CPU is a critical component that determines the server and the database performance. You can always start with the minimum and then adjust as you go based on your requirements. Here I am allocating 2 virtual CPUs, considering 2 major components such as the Oracle RDBMS and the OMS, which will run in the server. RAM or physical memory. The amount of memory is equally critical that determines the server and the database performance. I am estimating 4 gigs each for the RDBMS, OMS, and the OS, totaling to a 12 gigs of physical memory size. If you see a lot of paging happening in the server, you may increase it later on. Next, the swap. As per the Oracle recommendation, swap size should be calculated based on the size of the physical memory or the RAM, where for a RAM size between 1 to 2 gigs, the swap size should be 1.5 times the RAM size. For a RAM size between 2 to 16 gigs, the swap size should be equal to the RAM size. And for a RAM size over 16 gigs, the swap size should be also 16 gigs. So in our case, the swap memory size will be 12 gigs because our RAM size is also 12 gigs. Now the storage. I allocated a total of 70 gigs to the server while installing the Linux operating system, and that is divided amongst the root, boot, and the swap file system. But you can start with a minimum of 25 gigs allocation for the root, boot, and the swap file systems during the initial installation of the operating system. The temp file system should be of size 2 gigs minimum for Oracle installation. I am allocating 10 gigs as I am going to install OEM also in this server, and that demands more temp size while unzipping the huge installers of the OEM. Once the OEM installation is done, you can reclaim the space by reducing the temp file system size. Now, the file system named U001 is created with a size of 50 gigs for the Oracle RDBMS and the OEM or OMS binaries, logs, trace, and a dump file. Without the OMS installation in this server, you can have it with a size of around 15 gigs. The file systems named U002, U003, U004 are created with a size of 2 gigs each, and they will be hosting the 3 groups of redo logs and the multiplexed control files. The file system named U005 is created with a size of 40 gigs, which will host the data files. And the file system named U006 is created with a size of 25 gigs, which will host the FRA or the fast recovery area. Oracle recommends an FRA size of 3 times the database size, but as we are not going to keep the backup pieces here, so this should be fine. You can have it even smaller initially, like 20 gigs or so, then increase when required. If you create granted restore points and your flashback retention is very high, then probably you will need a lot of space in your FRA. Now let's put everything in action to create our Oracle 19c database, which we are going to use as our OEM repository database. So I logged into the server named admin SBR, which I call admin server, as Oracle user. Now let's go to the root directory and take a look at the file systems we created for their permissions. And these are the file systems that we created: U002, U003, 4, 5, and 6. The U001 we already used in the last tutorial to install our Oracle RDBMS software, and the ownership of the file system is already Oracle OInstall. But all the remaining file systems that we are going to use here are owned by root. So we have to first change the ownership to Oracle and group OInstall. To change the ownership of these file systems to Oracle OInstall, we have to log in as root because currently they are owned by root. So su minus root, and it will ask for the root password that we already know. And now we are as root user. Let's go to the root directory and change the ownerships using chown command minus capital R for recursive, Oracle OInstall, and all these file systems here: U002, U003, U004, U005, and U006. And if we see it again, now you can see that the ownership has been changed to Oracle OInstall. Let's clear it. Now we are ready to invoke the Database Configuration Assistant, or DBCA. Now, before running any Oracle utilities like DBCA, the Oracle environment should be properly set, which means the environment variables have to have the proper values. In our case, we don't have to set the environment because in the last tutorial, I have already shown how we can set these environment variables in the bash profile of the Oracle user, so that every time the Oracle user logs into the server, his bash shell will be automatically populated or automatically set with all the environment variables for his Oracle environment. So here we can take a look and see if all the variables are properly set by looking into the .bash profile of Oracle user. Here we can see that the Oracle base, Oracle home, LD library path, Oracle SID, Oracle unique name, TNS admin, and the path variable, everything is already set. Now clear this, and again, before invoking DBCA, we can see which DBCA is actually being invoked. So we see the path here, which is coming from the Oracle 13c home, which we installed earlier. So this is the right DBCA, which is going to create the database for us. But before we run the DBCA, the display variable should already have the IP address that belongs to the machine from where you are connecting to the Oracle server. Now we set the display variable with the IP address of the machine, and now we can invoke DBCA. Before we create a database, let's first delete the database that we created in the last tutorial, because that was just a test database we created to validate that our Oracle installation was properly done. So we'll click next, and the database that we created with the name ORCL is selected by default, and here we have to provide the sys password, and using this sys credential, this database is going to be deleted by DBCA. Here we don't have to select anything because this instance was not registered with any Oracle Enterprise Manager. Click next, and these are the files which are going to be deleted from the system. Click finish. It will ask for the confirmation. Click yes, and the deletion activity will take like a minute or so, and the database deletion is completed. Click close, as it doesn't give us the option to go back to create the database, and instead we have to invoke DBCA again. While creating the database, in the first screen, we will select the create a database option, then click next. We will select the advanced configuration option. Click next. The database type will be Oracle single instance database. We have other options here like Oracle real application cluster or RAC database, Oracle RAC one node database, etc. And we are selecting Oracle single instance database here, and we will select this option of the template here, custom database, which will give us more flexibility to choose the options, click next. Here we have to specify the global database name of the database that we are going to create, which will be OEM repo. And you can select any name here of your choice. Because we are going to create this database as OEM repository, so I am keeping the name as OEM repo. And I will unselect this create as container database because it's not a CDB. Click next. In this screen, we will select this option, use following for the database storage attributes, where we are selecting the file system option, and we have here the ASM option also, and the database file location will be our file system, which was created specifically to keep the database files, which is /u005, and rest of the directories will be automatically created. Then multiplex, redo log, and control files. We want to multiplex the control file and the redo log file for this database. Even if we have the option here for multiplex, redo logs, and control files, we are not going to select this option here and now because there is a bug associated in DBCA, and even if you select the multiplex option, those changes or the options you selected are not going to take effect. So we'll skip this. Then file location variable, here it is showing us all the file locations that are going to be used here, where it has given us the Oracle base home, DB unique name, Oracle base, PDB name, which is blank actually because there is no pluggable database, database name, OEM repo here, Oracle home, which is U001 app Oracle product 19.3 DB home 1, and this was created in the previous tutorial. And the SID of this particular database is going to be OEM repo. Then click next. Specify a fast recovery area. So here we are going to select the part U006, which we created for fast recovery area, and the size it's taking by default as 7 gigs. We'll keep it like this for now, and later on we will adjust it. And enable archiving, this option we are unselecting intentionally because we don't want to enable archive log mode while creating the database to avoid creating a large amount of archive logs. And we will click next here. And there is one listener already created in the previous tutorial while installing the Oracle software and creating the test database, and that listener was with a name listener itself, and it was listening at the port 1521. And this time we are not going to use that listener, so we'll unselect that, and instead we are going to create a new listener with the name listener OEM, and the port will be 1522. It is always recommended to use a non-default port for security reasons, and that is another reason why we are not going to use this default listener. And next we are going to select a few options, and the options we needed are already selected. We are not going to use the Oracle Level Security, Oracle Application Express, and Oracle Database Vault for this database, so we have unselected them all. Rest of the components which are selected by default, we are keeping them like that. Click next. And here we are using the automatic shared memory management, and as we have allocated 12 gigs of memory to the server, and I have already explained that out of 12 we are estimating that 4 gigs will be taken by the RDBMS, 4 gigs for the OMS, and rest of the 4 gigs will be for the OS itself. And out of the 4 gigs we are allocating 3 gigs to the SGA and approximately 1 gigs to the PGA. You can adjust it if you want the amount of memory used by this instance, but as of now we are okay with this, and if it is required we will be able to increase it in the future. And we are not selecting the manual shared memory management and automatic memory management here. Under sizing, the block size is 8 KB, which is the standard, and the processes parameter, it should be always set at a higher value like 2000. Then the character set, it is the Unicode character set selected by default, which is the best character set for our purpose, and the national character set, default language, and default territory, which are all selected by default. Connection mode will be dedicated server mode, and sample schemas we are not creating them in this database. click next. Now we can configure this database with a Enterprise Manager Database Express, but we don't want to do that now because anyway we are going to register this database with the OEM that we are going to install in the future. And similarly, register with Enterprise Manager Cloud Control will also be unselected because we don't have an Enterprise Manager Cloud Control yet. Click next, and we will use the same administrative password for sys and system OEM repo. So for now I am selecting a simple password here as the name of the database itself. Click next, and it's asking to confirm that I am okay with this password which does not meet the standard. Click yes. Now in this screen we will select the create database option here, save as database template, and generate database creation scripts. These are not required. Now this all initialization parameters, this is giving us an option to take a look at the initialization parameters that are selected or set by default. We will not make any change on them as of now, and if required we will be able to do that later on. Then click on this customize storage locations button, and this will show us all the locations that is being used for the different components or files. The control file distributed in two file systems, although we don't want to keep the control file in the U005 or U006 file system. Similarly, for the redo log files, we don't want to keep them in this file system U005, and instead we have created three separate file systems to keep the multiplexed version of the control file and redo log files. But even if we make any changes here, because of a bug, that change is not implemented by DBCA, so we are not going to make any changes here and let the DBCA choose the path. And once the database creation is completed, we will make our changes to create multiplexed version of the control file and redo log files. And for the table spaces, we see the size which is allocated. We are okay with that as of now. And all the data files also which are distributed in the U005 file system, which is as per our expectation. And these files are all with automatically extend on. And this is important because this is one of the criteria when you install OEM, and it will ask for setting the auto extension of the data files on. Now we did not make any change here, and we'll close this, then click next. And in this screen we get the last chance to review the different options we selected, and then click finish. And the database creation is going to take around 5 to 10 minutes based on the size. In this case, this is not going to take more than 10 minutes. And I will pause the video and we will resume once the database creation is completed. So our database creation is completed after around 10 minutes. We will close this window and we will validate a couple of things about the database. First, we'll go to the bash profile, and where we will adjust the environment variables that we set before. So vi, and here all the other things are good. We just need to modify this Oracle SID, which is going to be OEM repo, and also the unique name will be OEM repo. All the other settings are good, so we'll just leave it like that. Next, we will check the listener status. And we see there are two listeners running. One is the default listener that we created in the previous tutorial, and this listener underscore OEM is the one that we created in this tutorial just for the OEM repository database. Now we'll see the listener status. And in the status, we can see that our new database is successfully registered with the listener. Now we'll try to log into the database using system user, and we'll see if the TNS is properly working. System @OEM repo. This is the TNS entry that was created already, and the password will be same as the database name, and we are able to connect. Just for information purpose, I will also show you the TNS entry that was created. So clear the window and we'll do a cat of the tns names.ora file in this location, and this is the TNS entry that was created. So we have successfully completed creation of the database, and with this I am concluding today's tutorial. In the next tutorial, we are going to apply the standards and the best practices for an Oracle database before we install OEM and use this database as the OEM repository. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.